7b. The question here you see 7b, prove that the lines x is equal to az plus b and y is equal to cz plus d. This is one line. And x is equal to a1z plus b1 and y is equal to c1z plus d1. This is another line. Two lines are perpendicular if a1 plus c1 plus 1 is equal to 0. That means these two lines are given, they are perpendicular to each other. The lines are perpendicular to each other. Then we have to show that this condition is true. That is a1 plus c1 plus 1 is equal to 0. So first of all, you see the lines are given in unsymmetric form. So we have to bring the lines to symmetric form. So you see the symmetric form of this line, first line, that is, we should find out z in each case. Find out z in each case. That is, the symmetric form of the lines are x minus b by a is equal to y minus d by c is equal to z by 1. This is line L1. And the second line is x minus b1 by a1 is equal to y minus d1 by c1 is equal to z by 1. So this is line L2. You see, very simple equation is given. We can easily transform it to symmetric form. In each case, we can find out z. Here we can find out z. Here we can also find out z. Here also in the second equation find out z, and here also z. So the symmetric form of the equation is like this. Now the lines are known in symmetric form. So if two lines are perpendicular, so using the perpendicularity condition, we can find out this condition, or we can show that a1 plus cc1 plus 1 is equal to 0. So the DRS of line L1, is equal to AC1, and the DRS of L2 is A1 C1 1. So as they are perpendicular to each other, using perpendicularity condition, as L1 is perpendicular to L2 implies A into A1 plus C into C1 plus 1 is equal to 0. That is A1 A2 plus B1 B2 plus C1 C2 is equal to 0. So the perpendicularity condition is, you see, that is A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Using this condition, we have here A into A1, C into C1, 1 into 1, that is equal to 0. So this condition is obtained. So try to understand it. Two lines are there, L1 and L2, which are given in unsymmetric form. We should change the form of the equation, that is symmetric form, and in each case, very simple case of lines are given, That is, in each case we should find out z to change the form. So you see here equation 1 or the line L1 and line L2 are obtained in symmetric form. So we can find out now the DRS of L1 is AC1, the DRS of L2 is A1C11. As they are perpendicular to each other, applying the perpendicularity condition, that is A1 plus CC1 plus 1 is equal to